determine the minimum service size required for a 10-unit multi-family dwelling with two 8 kilowatt ranges in each unit, you'll need to follow a few steps. Firstly, determine the total connected load. This is calculated by multiplying the number of units by the number of ranges per unit, and then by the power of each range. In this case, the total connected load equals 10 units times 2 ranges per unit times 8 kilowatts, which equals 160 kilowatts. Secondly, calculate the demand factor. The demand factor is a value that represents the percentage of the total connected load that is likely to be in use at any given time. For multi-family dwellings, a demand factor is typically used. This factor acknowledges that not all ranges will be operating at their maximum power simultaneously. The specific demand factor to be used can often be found in local electrical codes or regulations. For the sake of this calculation, we'll assume a demand factor of 0.75. Thirdly, calculate the demand load. The demand load is the product of the total connected load and the demand factor. In this instance, the demand load equals 160 kilowatts times 0.75, which equals 120 kilowatts. Fourthly, determine the minimum service size. The minimum service size is the smallest size of electrical service that can safely supply the demand load. For a demand load of 120 kilowatts, a single-phase service might not be sufficient, depending on the voltage. A three-phase service is often required for larger loads in multi-family dwellings. The minimum service size for a three-phase service is often determined by dividing the demand load by a factor of 0.8. This is based on common transformer loading practices. In this case, the minimum service size equals 120 kilowatts divided by 0.8, which equals 150 kilovolt amps. Therefore, the minimum service size required for a 10-unit multi-family dwelling with two 8 kilowatt ranges in each unit is 150 kilovolt amps. It is critical to consult local electrical codes and regulations, as they may have specific requirements or modifications to these calculations. These codes ensure the safety and reliability of electrical installations. Always involve a qualified electrician or electrical engineer for the design and installation of electrical services. Their expertise ensures compliance with all applicable regulations and best practices. Let's delve a little deeper into the concepts involved. The total connected load represents the sum of all the electrical loads that could potentially be operating simultaneously. However, in reality, it is unlikely that all loads will be running at their maximum capacity at the same time. This is where the demand factor comes into play. The demand factor is a multiplier that reduces the total connected load to a more realistic estimate of the actual load that the electrical service will need to handle. Demand factors are typically based on historical data and statistical analysis of electrical usage patterns. Different types of loads, such as lighting, appliances, and heating systems, may have different demand factors. Electrical codes often provide tables of demand factors for various types of loads and occupancies. The demand load is the product of the total connected load and the demand factor. It represents the estimated maximum load that the electrical service will need to supply at any given time. The minimum service size is the capacity of the electrical service that is required to safely and reliably supply the demand load. The service size is typically expressed in kilovolt amps, which is a measure of apparent power. The service size must be large enough to handle the demand load, plus any additional loads that may be added in the future. It is also important to consider the voltage and phase of the electrical service. Single-phase services are typically used for smaller loads, while three-phase services are used for larger loads. The voltage of the service must be compatible with the voltage of the equipment that will be connected to it. Let's consider a practical example. Suppose a multi-family dwelling has 10 units, and each unit has the following electrical loads. Firstly, lighting load of 2 kilowatts. Secondly, appliance load of 3 kilowatts. Thirdly, a heating load of 5 kilowatts. And fourthly, a range load of 8 kilowatts. To calculate the total connected load, we would add up all of the individual loads. The total connected load would be 2 kilowatts plus 3 kilowatts plus 5 kilowatts plus 8 kilowatts multiplied by 10 units, which equals 180 kilowatts. To calculate the demand load, we would multiply the total connected load by the appropriate demand factors. Suppose the demand factor for lighting is 0.8, the demand factor for appliances is 0.7, the demand factor for heating is 0.6, and the demand factor for ranges is 0.75. The demand load would be 2 kilowatts times 0.8 plus 3 kilowatts times 0.7 plus 5 kilowatts times 0.6 plus 8 kilowatts times 0.75 multiplied by 10 units, which equals 127 kilowatts. To determine the minimum service size, we would divide the demand load by 0.8. The minimum service size would be 127 kilowatts divided by 0.8, which equals 159 kilovolt amps. Therefore, a 160 kilovolt amp service would be required for this multi-family dwelling. Remember that it is important to consult local electrical codes and regulations, as they may have specific requirements or modifications to these calculations. Additionally, the calculation presented used a demand factor of 0.75. However, NEC Table 220.55 permits demand factors that vary based on the number of appliances installed. For example, if there were only 2 ranges, the demand factor would be 80% of the sum of the nameplate ratings instead of 75%. The minimum service size calculation is crucial for ensuring that a building's electrical system can safely and reliably handle the anticipated load. If the service size is too small, it can lead to overloaded circuits, voltage drops, and even electrical fires. Conversely, if the service size is too large, it can result in unnecessary costs and wasted energy. It is essential to work with qualified professionals who can accurately assess the building's electrical needs and determine the appropriate service size. These professionals will consider all relevant factors, including the building's size, occupancy, and the types of electrical equipment that will be used. They will also ensure that the electrical system complies with all applicable codes and regulations. In addition to the minimum service size, it's also important to consider the capacity of the individual branch circuits within the building. Branch circuits are the circuits that supply power to individual outlets, lights, and appliances. Each branch circuit must be sized appropriately to handle the load that it will be serving. Overloaded branch circuits can also lead to electrical hazards. The National Electrical Code, or NEC, provides detailed guidance on how to size branch circuits. The NEC specifies the maximum allowable load for different sizes of conductors and overcurrent protection devices, such as circuit breakers and fuses. It's crucial to follow the NEC guidelines when designing and installing branch circuits. Electrical calculations can be complex, and it's always best to seek the assistance of qualified professionals. A licensed electrician or electrical engineer can perform the necessary calculations and ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. They can also provide valuable advice on energy efficiency and cost savings. When planning an electrical installation or upgrade, it's important to consider future needs. As technology advances, buildings are likely to require more electrical power to support new devices and systems. It's wise to design the electrical system with some extra capacity to accommodate future growth. This can help avoid costly and disruptive upgrades later on. Furthermore, regular maintenance and inspection of the electrical system are essential for ensuring its continued safety and reliability. Electrical components can deteriorate over time, and loose connections or damaged wiring can create fire hazards. A qualified electrician can perform routine inspections and identify any potential problems before they become serious. In summary, calculating the minimum service size for a multi-family dwelling with electric ranges involves several steps, including determining the total connected load, calculating the demand factor, calculating the demand load, and determining the minimum service size. It's crucial to consult local electrical codes and regulations and to work with qualified professionals who can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that electrical safety is paramount. Always take precautions when working with electricity and never attempt to perform electrical work unless you are qualified and authorized to do so. Electricity can be dangerous, and it's important to treat it with respect. By following these guidelines, you can ensure that your multi-family dwelling has a safe and reliable electrical system that meets the needs of its occupants. Keep in mind the importance of demand factors in accurately estimating the electrical load. The demand factor accounts for the fact that not all electrical appliances and equipment will be operating at their maximum capacity simultaneously. This allows for a more realistic assessment of the actual load that the electrical service will need to handle. Demand factors vary depending on the type of load and the occupancy of the building. Electrical codes provide tables of demand factors for various types of loads and occupancies. It's important to use the appropriate demand factors for this specific application. In addition to demand factors, it's also important to consider diversity factors. Diversity factors are similar to demand factors, but they apply to groups of loads rather than individual loads. For example, a diversity factor might be used to account for the fact that not all of the apartments in a multi-family dwelling will be using their ranges at the same time. Diversity factors can further reduce the estimated electrical load. The selection of appropriate demand and diversity factors is a critical aspect of electrical system design. It requires careful consideration of the building's occupancy, the types of electrical equipment that will be used, and the expected usage patterns. Experienced electrical engineers and designers have the knowledge and expertise to make informed decisions about demand and diversity factors. When in doubt, it's always best to err on the side of caution and use a higher demand or diversity factor. This will ensure that the electrical system has sufficient capacity to handle the actual load. Overestimating the load is generally preferable to underestimating it, as an undersized electrical system can lead to serious problems. Consider also the long-term implications of electrical system design. Buildings are often used for many years, and their electrical needs may change over time. It's important to design the electrical system with some flexibility to accommodate future growth. This may involve installing larger conductors or using modular equipment that can be easily expanded. Planning for the future can help avoid costly and disruptive upgrades later on. Finally, remember that electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest requirements and to ensure that all electrical work is performed in accordance with applicable codes. The electrical codes are designed to protect people and property from electrical hazards. Compliance with these codes is essential for ensuring the safety and reliability of electrical systems. In conclusion, calculating the minimum service size for a multi-family dwelling with the electric ranges is a complex process that requires careful consideration of various factors, including the total connected load, demand factors, diversity factors, and electrical codes. It's always best to seek the assistance of qualified professionals who can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. The calculations are just a part of the process. It's also important to consider the selection of electrical equipment, the installation methods, and the ongoing maintenance of the system. A well-designed and properly maintained electrical system will provide years of reliable service and protect the safety of building occupants.